So now we're going to move on to assignment number 3, and we're really going to do two things in assignment number 3. One is order numbers that are in scientific notation, and then the second thing that we're going to do is we're going to be multiplying numbers that are in scientific notation by another number. And so let's go ahead and get started. So let's first take a look at the mass of each of these different planets. So we have the first planet, Uranus, 8.7 times 10 to the 25th. Again, all of these numbers here are in scientific notation because their mass is just too big to write in a regular way. But we want to put them in order from the smallest to the biggest planet. And so the first thing that we're going to do is look at the exponent that they have. The bigger the exponent, the bigger that number is. And we can see that 25 is the smallest. And so the smallest planet here is the 8.7 times 10 to the 25th. So when we put these in order, the smallest one is going to be Uranus. And I'm just going to put a 1 down here because that's the smallest. Then we have two planets that have the same exponent here, 10 to the 26th. And so this decimal would be moved 26 spaces to the right. This decimal would be moved 26 spaces to the right, but because 1.0 is less than 5.7, this is going to be the second smallest planet. And then Saturn is going to be the next smallest planet. The biggest planet is actually the one with the biggest exponent. So 3.7 times 10 to the 27th is the biggest planet because this would be 27 spaces to the right, which is actually 10 times bigger than anything that would be 26 spaces, or 100 times bigger than anything that is 25 spaces to the right. And so when we put them in order, the first thing we have to do is look to make sure that they're in scientific notation. Once we see that they're all in scientific notation, we look first at the exponent and then we look at the actual number. So let's take a look at these numbers. We want to put these numbers in order. So you can see that they are not in scientific notation. If we move this first one and put this first one in scientific notation, we are going to do something like this. Let me get this so that I can. I'm going to start by putting this one in scientific notation, which is going to be 6.0. So I start with the first digit, which is the 6, 0.0, and then it's going to be times 10 to a power. And so if right now it's times 10 to the 7th, which would be 7 spaces in this direction. But if I move the decimal 1, 2 spaces to get the decimal where it's supposed to be, then it's only going to be times 10 to the 5th. And so A would be 6.0 times 10 to the 5th if I wrote it in scientific notation. B is also not in scientific notation. I'm going to write this one as 6.1 times 10 to a power. So right now the decimal is here, and this says to move it 3 spaces to the right. But I want to move the decimal here, which means I'm going to have to move it 1, 2, plus those 3 spaces to the right. So that's going to be 6.1 times 10 to the 5th. C is also not in scientific notation. It's 68, but I would want to write that as 6.8 to put it in scientific notation. Right now the decimal is here, and it's 4 spaces to the right, but if I want to put the decimal here between the 6 and the 8, it would be 1 plus those 4 spaces, which is going to be times 10 to the 5th. And then the last one, again, it's not in scientific notation. I want to start with the first number and then the decimal point. So instead of 0.59, it's going to be 5.9. This says to move the decimal 6 spaces to the right if I start it from here. But I want to move the decimal here. So I've already moved it 1 space to the right, so I only need to move it 5 more spaces to the right to get it into scientific notation. And so now I want to put all these numbers in order from smallest to largest. You can see that all of the exponents are the same. They're all 5. So then I'm just going to look at the actual numbers. The smallest number is letter D because it's 5.9 times 10 to the 5th. Then we have the 6.0, which is letter A. Then we have the 6.1, which is letter B. And then the biggest number is letter C, which is the 6.8 times 10 to the 5th. So again, we have to make sure that all of these, we're talking about the same thing, which means all of them have to be in scientific notation. And then we look at the exponent first, and then if the exponents are the same, then we look at the actual numbers. Let's take a look at number 3 here. So ordering numbers works the same if they're small numbers. And so we have neutrons, electrons, and protons here. And so you can see all of these are in scientific notation because we have a number and then the decimal and then the rest of the digits. And so the smallest one of these is going to have the smallest exponent. Well, negative 28 is actually smaller than negative 24. And so the smallest one of these is going to be the electron, is the smallest. And then we have the neutron and the proton both have an exponent of negative 24. So those decimals are going to be lined up, but then we have to look at the actual numbers. Which one is the smallest number? We have 1.672 is smaller than the 4. And so the next smallest one is the proton. And the biggest of these is the neutron. And so when we put these in order, again, we want to make sure first they're in scientific notation, then we look at the exponents. If the exponents are the same, then we look at the actual numbers. Let's take a look at second thing that we're going to be talking about during this video is multiplying numbers that are in scientific notation. So here we have a number in scientific notation, 6 times 10 to the third, and then we're going to multiply that times 12. So we could think about this like this. We can make this as 12 times 6 times 10 to the third. So I really don't need the decimals there. I want to multiply the things that I can multiply together, like for example, 12 times 6. Well, 12 times 6 is 72 times the 10 to the third. Well, that is a correct answer, but it's not in scientific notation. And so right now the decimal is here. And the 10 to the third means that we're going to move it 3 spaces to the right. But I don't want the decimal there. I want the decimal between the 7 and the 2, which means I'm not going to move it 3 spaces to the right. I want to move it 1 plus the 3 spaces to the right. And so it's going to be 7.2 times 10 to the fourth. I'm going to do the same thing here for number 5. I'm going to multiply the 0.4 and the 2.1. The 0.4 and the 2.1, if I multiply those together, that is going to give me 0.84 times 10 to the negative 9th. And so the decimal is here, but that's not where I want the decimal to be. I want the decimal to be between the 8 and the 4. This number here means to take, because it's times 10 to the negative 9th, I'm going to move the decimal here 9 spaces to the left. But if I put the decimal where I want it to be, I'm going to have to move it 1 plus those 9 spaces to the left, which is 10 spaces to the left. So my actual answer is going to be 8.4 times 10 to the negative 10th. These are the kind of things that we're doing on our homework assignment for tonight. Good luck with that, and we will see you more and talk more about this in class tomorrow.